Alright guys, if you've been struggling with this unit, this is the lesson that you need to listen to, watch, pay attention to, and get really good with. Because matrices will make your life a whole lot easier. So it says the students will solve systems using matrices. And how do we use a matrix equation to solve a system of equations? Alright, so identifying inverses. You have two options. You can either multiply these together, because when you do that, so when inverses are multiplied, we get the identity matrix. Identity matrix, which we have two of them. Two main ones. The 2 by 2 looks like that. The 3 by 3 looks like this. Alright, so if when you multiply you get these matrices, then they're inverses. That's one option. Or you can take one of them and raise them to the -1. I'm going to show you both methods with this problem real quick, and then I'll let you guys do this one. Alright, so actually we'll probably just do them both. So if I'm going to multiply those, I need to go to my calculator. Alright, so we're dealing with two 2 by 2s. So we want to press this button. You want the 2 by 2. Then the numbers are -4, -2, 2, and 1. -4, -2, 2, and 1. Alright, so multiply. We want another 2 by 2. And then we're going to have 1/4. So control divide. 1 divided by 4. Below that we have half. Then we have -half. And we have finally -1. Alright, so when I multiply those together, I get all zeros. That is not the identity matrix. So, according to that, these are not inverses. Now, I'm going to check it by doing it this way. So again, we want the 2 by 2. We're going to put -4, -2, 2, and 1. Now we're going to raise this to the -1. So we have to use this caret button here below equals and just put in -1. And you get this error. If you get this error right here, singular matrix, once you hit OK, singular matrix, that means that there is no inverse. So this has no inverse. And since it has no inverse, this one can't be its inverse. So easiest way is probably to just raise this one to the -1. So if we take this one, raise it to the -1, so again we're dealing with a 2 by 2, and our numbers are 3. Below that we have -2. Over here we have -5, and then we have +6. So we're going to raise that to the -1. And we get 3/4, 5/8, 1/4, 3/8. So let's check it. So 3/4 good, 5/8 good, 1/4 good, 3/8 good. In this case, yes, they are inverses. Alright, so finding inverses. We just did that. So you take this and you raise it to the negative 1. So 7. Alright, so we come back to our calculator. Again, we're dealing with a 2 by 2. So we have 7. Below that we have 2. Over here we have negative 5. And below that we have negative 1. And then we're going to raise that to the negative 1. And we get that it is negative 1/3. So I'm going to write that down. So negative 1/3. Below that is negative 2/3. Over here we have 5/3. And then we finally have 7/3. And that is the inverse to this matrix. Alright, so let's try the next one. So again, we have a 2 by 2. And this is negative 8. Below that is 12. Got negative 6. And below negative 6 is 9. Raise it to the negative 1, and it gives us that error again, singular matrix. So this is no inverse. Alright, so pause it here, try this one on your own, and then we'll check back with you. Alright, so you should have paused it, tried this one on your own. Let's check to see what we get. Again, we're dealing with a 2 by 2. So we have 3, 1, up here's 7, and down here's negative 4. Alright, so let's get out of our matrix, raise it to a negative 1, and when we do, we get this. So we get 4/19, we get 1/19, we get 7/19, and we get negative 3/19. Alright, how are we going to use all of this to solve these systems? Well, we have what we call a matrix equation. Alright, so matrix equation. Alright, the matrix equation is the coefficient matrix times the variable matrix equals the constant matrix. Alright, so our coefficient matrix is, alright, so as I was saying, the matrix equation is the coefficient matrix times the variable matrix, which is equal to the constant matrix. So let's fill that out. So the coefficient matrix, we have our x's this way, so that's 1, 3.75 because they're the coefficients of x. We have our y's going down this way, so that's 1 and 3.5. Alright, variable is x and y, and that's equal to our constant, which is 24.2 and 88.05. Alright, so when we do this, the way we get the answer is it is the inverse of this one. So it's the inverse of the 1, 3.75. And by inverse, I mean raise it to the negative 1 times 24.2 and 88.05. And yes, I did make a mistake up here. This is 24.2, not 2.24. So in case someone caught that, change that to 24.2. Alright, so we're going to multiply those. Alright, so we want our 2 by 2 matrix, which is 1, 3.75. Up here is 1. Down here is 3.5. We're going to raise that to the negative 1. And then we're going to multiply that by our, and it looks like this one. It's a 2 by 1. We're going to take that one there. That's 24.2 and 88.05. And when we do that, we get our answer of 13.4 and 10.8. So the answer to this is 13.4 and 10.8. And you could plug it back in and check it. So if I do that, 13.4 plus 10.8 is 24.2, which is what it's supposed to be. And then 3.75 times 13.4 plus 3.5 times 10.8 gives me my 88.05, which is what I'm supposed to have. So we know we're good. So this is X. That's Y. Alright, so let's try this one. So our matrices, so we have negative 4, 4, 2, negative 3. We want the inverse of that one times this one, 3, negative 6, right? So that's going to be a 2 by 2. We got negative 4. Positive 4, 2, negative 3. We're going to multiply that by this one here, which is 3 and negative 6. Oh, I did forget something, didn't I? We got to raise this to the negative 1. Don't forget that. It's the inverse of this one, raising it to the negative 1. And when we do that, we get our answer of 3/4 3. So the answer to this is 3/4 and 3, which means X is 3/4, Y is 3. So how you would see that as an ordered pair would look like that. Alright, that's this lesson. This is going to make your test a whole lot easier right here. 1, you have a question about this. 2, there's it's systems. A lot of your systems of equations can be solved this way. You just have to make sure that all your variables are on the same side. Alright, so if you have any questions, let me know. I will be up there for tutoring on Wednesday, which is the day before the test, so anyone who wants to come by and we will get some work done. Alright?